Good morning, children. In the earlier video, we have seen the image formation diagrams in the case of convex lenses. So we have drawn all the, I think you all also have drawn all the image formation diagrams, and in that the first one was the object was placed beyond 2f, and when the object was placed beyond 2f, the image was formed between f2 and 2f2. It was real, inverted and smaller than the object that is it was diminished. Second is when the object was placed at 2f, and when the object was placed at 2f, the image was formed at 2f only. It was real, inverted and the same size as that of the object. And third is when the object was between 2f1 and f1, and when the object was between 2f1 and f1, the image was formed beyond 2f2. It was real, inverted and larger than the object. Larger than the object means magnified. Okay. And fourth one was when the object was placed at f1. And when the object was placed at f1, that is focus, you saw the refracted rays, both the refracted rays, that is the ray which was parallel to principal axis, that one which passed through the focus, that one, and another ray from B which passed through the optic center, that also, both these rays were parallel. And since these rays were parallel, the main thing what happened was we assumed that these will meet at infinity. So an enlarged real image would be formed at infinity or at a large distance. And the last one we saw when the object was placed between O and F, between the optic center and F1. And when the object was placed between the optic center and F1, you saw both the refracted rays were moving away from each other, that is, they were diverging away from each other, hence they were produced behind, and when they were produced behind, they met and it formed an erect virtual image larger than the object, and the image was formed on the same side of the lens, not on the other side of the lens. Okay, this is what we have seen till now. Now we will see image formation in the case of concave lenses. So I will write that on the board. Okay, and for image formation in the case of concave lenses, we have only two cases. The first case is when the object is placed at infinity, and the second case is when the object is placed between infinity and the optic center. Only two cases. First is when the object is placed at infinity. So I will draw one concave lens. So you can draw like this, a concave lens, and then you can draw one line at the center, and after drawing the line at the center, you can draw the principal axis. So I have drawn the principal axis. After drawing the principal axis, let us mark F1 to F1, F2 and to F2. For that, you need to take the measurements from O. So for that I will take the measurements from O. I will extend this principal axis on the other side also. So I have marked here the optic center, then F1, 2F1, F2 and 2F2. Okay, so I have done this much. Now after this, okay, we will place an object at infinity, and when an object is placed at infinity, draw it in such a way that half part of it is above the principal axis and half part of it is below the principal axis. So I will draw that. Okay. So let it be erect like this. First take a ray parallel to the principal axis like this. From here also take a ray parallel to the principal axis, because the rays coming from infinity are always parallel. Like for example, we get the parallel rays of the sun because the sun is at a far distance from us. Okay, after drawing these both rays, concave lens is a diverging lens. Concave lens is a diverging lens, that is, after diffraction, the rays of light appear to diverge from the focus. So they will diverge from the focus. So you can, from the focus, you can keep the scale like this, and you can draw this diverging ray this side, and the same case this side also. See here, hope you can see. So this way, the rays of light will, after refraction, will get diverged. Since they will not meet this side, we have produced them behind, and the image is formed at F1. So the image is formed at F1. It is virtual because it is formed by producing the refracted rays, virtual and point sized. You can see it is point sized. Okay. So the image will be formed at F1. It is point sized and it is virtual and point sized. Now this is about the image formation diagram for a concave lens when the object is placed at infinity. Okay, here the object is placed at what? Infinity. So I will write here object at what? Infinity. Okay, draw this ray diagram. Okay, now we'll see when the object is placed, okay, between infinity and the optic center. Anyway, for that we need to place the object just above the principal axis, not like this, half above and half below. Okay. So now we will draw the next image formation diagram for a concave lens when the object is placed between infinity and the optic center. So I will just place the object here. Anywhere you can keep this object. Let this be above the principal axis like this. Now one ray from B you can take parallel to principal axis. Okay, one ray you have taken parallel to principal axis. And next what you do is from F, okay, it will get diverged. Okay, so here like this, draw a dotted line here and from here a solid line. Okay, and another ray of light you have to take from B itself but through O. Okay, so that also I will draw. And that will pass without bending. Okay, and this ray will pass without bending. Now you can see this ray which is produced behind here, because this ray will get diverged from the focus from F1. Okay, now this ray which is produced backwards and the ray passing through O, both have intersected here. Both have intersected here above the principal axis, so the image is formed here. So I will mark it as A dash B dash. Since it is erect, it is virtual. Okay, so the image is virtual. Okay, erect, and you can see it is smaller than the object. Smaller than the object. Okay, this is about the image formation diagrams in the case of a concave lens. Okay, draw these image formation diagrams. Draw them, everyone. So we will stop here for today, and the next part of the lesson we will see in the upcoming videos. Okay, and tomorrow we have online class, that is on Thursday at 9 a.m. So please do join in big numbers. Okay, thank you.